Okay, you are welcome to the Introductory Mathematical Analysis A. Alright, again we are going to continue with our chapter 11 and we are going to do some examples there. Some examples mainly is in quotient rule and chain. Quotient rule and chain rules. Okay, that's what we are going to focus on. Okay, so let's start with example 1. Let's start with example 1. Okay, in this example 1, we're going to find if y equals to x squared minus 4x plus 3 all over 2x squared minus 3x plus 2. Alright, so we want to find y prime. Want to find the derivative of y if we are given that y equals to that. Alright, so if you look at this can be called like u and this v. So obviously we are supposed to use quotient rule on this. We are supposed to use quotient rule. Alright, and again, when you are using quotient rule, don't forget you are supposed to derive the numerator first. We are deriving the numerator first. Please take note of that. So let's go. So we have our y prime to give us as this formula, u prime v minus uv prime all over v square. Okay, you can use that formula. Or you can just simply derive your numerator first, multiply by the denominator, minus derive the denominator, multiply by the numerator over the denominator square. Okay, so let's go with that. So we're going to be having our u. Okay, so you derive the numerator, you have 2x minus 4. Okay, that is the derivative of the numerator. You must multiply it by the denominator. Alright, now again you need to write the numerator. You need to write the numerator and then multiply by the derivative of the denominator. Derivative of the denominator, 4x, then minus 3. Okay, then we put everything over the denominator square. Okay, that is it. That is our derivative of that y. Okay, if you are asked to simplify, then you can just simply multiply out this one. Simply multiply out this one and take together the common terms and then simplify it. But if you are not asked to simplify, just leave your answer the way it is. Just leave your answer the way it is. Alright. That is fine. Please hope you are able to understand. Ensure that you understand. Okay, let's go to example 2. Let's go to example 2. In example 2, we are given if f of s is given as this one, okay, if f of s is given as this one, we are asked to also find the derivative of f of s. Okay, again, don't forget that this is f of s, not x. Okay, so the derivative, this you are looking for, is the same thing as the f over the s, not the x, not this one, not this one. What you are differentiating with respect to, depending on the function of the f or the function, the s, the variable f is depending on, or the variable y is depending on. Okay, please take note of that. So to find out the f over the s, okay, first we can recognize that this is the same thing as 17 over 4s4 plus 5s squared minus 23s. Is the same thing as that. The same thing as that. Now, if you want to derive, you can also use quotient rule because the function is at the denominator. Okay, remember one of the example we did before when the function is at the numerator and the constant is at the denominator. There's no need to use quotient rule on that one. Okay, so again, here you have to use quotient rule, or we're going to see an alternative way of also deriving that. Okay, but for now, let's use the quotient rule on this one. So again, this will be our u, this will be our v. Okay, this will be our u, this will be our u, and this will be our v. Okay, so let's derive that. Don't forget you are deriving the numerator first. So the f over the s will now be given, derive the numerator first, which will become 0. Okay, multiply by the derivative of this. No, you just multiply by this one, not the derivative. Don't forget, we have already derived the numerator. Okay, minus, write this one, then derive the denominator, 16s3 plus 10s minus 23. Okay, all over the denominator square, 4s4 plus 5s square minus 23s square. Okay, that is it. This is 0, or this becomes 0. So we are going to be having minus 17 into 16s3 plus 10s minus 23, then all over 4s4 plus 5 square minus 23s all square. Okay, that is the answer. Of course, you may simplify further if they want you to do so, but I think you can just leave it like this. Okay, all right, that's fine. But alternatively, you can convert these to a form like this, So alternatively, f of s can now become 17 4s4 plus 5s squared minus 23s raised to the power minus 1. Okay, so the original f of s given to us, we just decide to write it now this way. We decide to write it this way. Then we can now use chain rule on this. So to find the f over the s, we can use chain rule. How do we do that? Bring this down to become minus 17. Your inner function will remain the same first. Okay, you are deriving the outer function first. Okay, so this is the derivative of the outer function. Now we need to derive the inner function. multiplied by the derivative of the inner function, which will become 16s3 plus 10s minus 23. Okay, so this is the derivative of the inner function. Here, this is the derivative of the outer function. And the inner one is not moved, is not derived. We just leave it the way it is. All right, so we can rewrite this one. If I rewrite this, I'm going to be getting minus 17. This is multiplication, so it will be 16s3 plus 10s minus 23. Then all over this one, 4s4 plus 5s squared minus 23s all raised to the power 2 now. All right, so if you compare this with what we have before, it's the same. If you compare that with what we have before, it's the same. Okay, so we can either do that way. Okay, sometimes the quotient rule can be converted to something like a product rule or like a chain rule, and then you can also still do that way. So if you are not asked to use a particular rule, you can use any of the rule. You can change it into any of the rule to be used, like in this example. But if you are asked to use chain rule, it is stated that you should use chain rule to find the derivative. Then this is how to go about it. This is what to use. Please stick to the rule you are asked to use. Except you are not given any rule to use, then you can use any one you like. All right, please take note of that. Example 3. Okay, in this example 3, we have if y is given as 4u3 plus 10u squared minus 3u minus 7, and u is given as 4 over 3x minus 5. Okay, so we want to find the y over the x when x is equals to 1. Okay, that's what we are asked to do. We have to find the y over the x when x equals to 1. Okay, so what we need to do in order to solve this, notice that y is a function of u here is a function of x. So we need to find the y over the u first. Then we find again the u over the x. All right. Now we are given x equals to 1, but we don't know what will be u. So you need to put x equals to 1 into this expression to get what will be u. Okay, let's go, and then things will be clearer to you. Let's find the y over the u first. Okay, let's find the y over the u. Let's find the y over the u. Okay, the y over the u will be what? Will be 12u square plus 20u minus 3. Okay, that is the y over the u. Okay, that is the y over the u. Okay, let me quickly find something. Let me quickly find what will be u when x is 1. So let's put this value of u of 1. What will be u of 1? Let's find u of 1. U of 1 will now become 4 over 3, 1 minus 5. This will be 4 over minus 2, which will become minus 2. Okay, so when x is 1, u will be minus 2. So I can simply find this now. I can simply say the y over the u at u equals to minus 2 will give us this 12 minus 2 square plus 20 minus 2 minus 3. Okay, this should give us 48 minus 40 minus 3. That should give us 5. Okay, so the y over the u at u equals to minus 2 equals to 5. All right, so let's now go to the u over the x. Okay, so the u over the x, again, we can turn this u into something like this. We can turn this u into something like this. U equals to 4, 3x minus 5 minus 1. Okay, we can turn u into something like this. All right, so it's easy to derive this way, so to say, but if not, you must use a quotient rule on this. If you don't want to turn it this way, then use a quotient rule and then you can get it. But let's derive it this way. So we are going to be having minus 4, 3x minus 5 minus 2. That is the derivative of outer function. Then multiply by the derivative of inside, which is 3. Okay, with that now, we have minus 12, 3x minus 5 minus 2. Okay, and this can also be written this way: minus 12 over 3x minus 5 raised to power 2. All right, that is the u over the x, but we need to find the u over the x when x equals to 1. So I said the u over the x at x equals to 1. What will be that value? That will be minus 12. Okay, let me shift this a little down so that you will not be thinking. Okay, let's write it properly. Okay, so the u over the x at x equals to 1 is minus 12 over 3, 1 minus 5 all square. Okay, all square. This gives us minus 12 over, this is minus 2. Minus 2 square is 4. That will give us minus 3. Okay, that gives us minus 3. Okay, that's fine. So we have the u over the x when x equals to 1 to give us minus 3. We have the y over the u when u equals to minus 2 to give us 5. But don't forget, for us to get our dy over the x that we are looking for, is going to be dy over the u multiplied by the u over the x. And we're evaluating it at x equals to 1, and the x equals to 1 was transferred to u to give us u equals to minus 2. So that means now we now have 5 multiplied by minus 3. And that gives us minus 15. Okay. I hope you are able to understand. Please ensure that you understand. All right. Thank you. Thank you so much.